Here's number 52 from section 3.2. The position of a body moving along a coordinate line at time t is s equals 4 plus 6t to the power of 3/2 with s in meters and t in seconds. Find the body's velocity and acceleration when t is equal to 2 seconds. So we're given a position function, and we want to find the velocity and acceleration. So if the position is s equals 4 plus 6t to the 3/2, and we want velocity, we're looking to find the derivative of the position function. So let's begin with that. So s prime is v in this case. So v is s prime. And by the chain rule, we're going to take a 3/2 to the front. We're going to leave the inside alone, 4 plus 6t. Now we're going to reduce that exponent. So 3/2 minus 1 is 1/2. And then we're going to multiply by the derivative of the inside function, which is 6. And finally, we're going to simplify that. 3/2 times a 6. I'm multiplying those two coefficient factors. And we should end up there with 9 times 4 plus 6t to the power of 1/2. Now, we're asked to find the velocity and acceleration, not in general, but when t is equal to 2 seconds. So let's get to that. V of 2 would then be equal to 9 times 4 plus 6 times 2 to the power of 1/2. So that's 9 times 4 plus 12, so 9 times 16 to the half. Well, 16 to the half is like asking for the square root of 16, so this is 9 times 4, and here we're going to have 9 times 4 is 36. And since we're measuring s in meters and t in seconds, this is meters per second. Let's move to the acceleration, and we know that acceleration is the derivative of velocity. A is the derivative of v, or it's s double prime. So let's find the derivative of the velocity function. We're going to take the 1/2 and move it to the front to multiply by 9, and that's going to be then 9/2. We're going to leave that inside function as 4 plus 6t. We're going to reduce the exponent by 1, so 1/2 minus 1 is negative 1/2. And then we're going to multiply again by the derivative of the inside function, which is 6. So that's going to give us 18 times a 4 plus 6t to the power of negative 1/2. Now, we want to find the acceleration, again, like the velocity, where time is equal to 2 seconds. So we want a of 2. So that's going to be 18 times 4 plus 6 times 2 to the power of negative 1/2. So here we have the 18 again. The 4 plus 6 times 2, that's 4 plus 12, which is 16. To a power of negative 1/2, I'm going to write that now in the denominator as a root 16. So this turns out to be 18 over 4, which reduces to 9/2 or 4.5. It's an acceleration, so it's meters per second per second. I'm going to write that as meters per second squared. So there's an answer, and that finishes up number 52.